Good evening to you from A&E in Chico, California. This is a special late night presentation. I'm supposed to be on sabbatical, but there is a point that needs to be brought out, and I would like to mention that and just a few other subjects in this lecture, but this isn't really a formal lecture. Well, of course, very few of my lectures are formal. Although I am getting more formalized. Um, I I've been forced to confront some nomenclature, which, due to the nature of the work that we're doing in geometry at this cutting level, it is inevitable that some of the terminology in use conventionally and by myself needs to be brought into closer alignment. And it's a delicate point for all of us because we're used to using words in a certain way, but in science, this shifts constantly. Words become more specialized in meaning and change in meaning and have more than one meaning over time because of the limitations of our language and the need for continuity, that we're trying to maintain continuity with ideas that we do know through words, of course. But as science progresses, of course, well, we need new words. We actually do need new words. Now, in the case of what I want to talk about and need to talk about, this is a high level but subtle point. It's the difference between the word dimension and proportion, which may not look at first as if these two words have any relationship, except they're obviously geometric words. Dimension, what exactly is a dimension? We talk about the first, second, and third, and now, of course, the fourth dimension. So 4 dimensions, wow. What does this mean? I mean, it's a reasonable question at any time in science. This is why professors tell their students relentlessly, do not be afraid to ask questions. It's actually the stupid questions that are the best. Although there is such a thing as a genuinely stupid question, but even if that happens, it should never cause shame or guilt. It's just simply you have to think out loud sometimes. We call those questions. When you're thinking out loud, it's a question. Okay, so we talk about dimensions, and I have in several lectures. Of course, what I'm dealing in is pure dimensionality, but you see, here's the subtle and high level point. I'm actually not any longer talking about dimensionality in the conventional sense. And I've noticed that I've shifted between the two, which means that I've been negligent in coming up with a new word. I tried, but I didn't choose the right word. Because what I need is a replacement for the word dimensionality. And I'm going to be explaining that now briefly. This is actually not a difficult point to understand, but it's a very difficult point to explain so that you might understand it. What is it that I have noticed that is causing, obviously, some anxiety here? I'm trying to resolve something because science is precise. It really has to be. But in the case of words, we simply can't be. We were as precise as we can be, but it's imperfect. So dimensionality has to do with a straight line. It's not explicitly taught with enough emphasis, I think, because there's nothing to compare it with. In other words, when we say first, second, third, and fourth dimension, we already know what we're talking about, and it is the straight line. But you see, we're not using straight lines anymore in the integral geometry is explicitly the integral of straight lines into another space. There's no linearity in the space that I've composed. Well, I haven't composed it, I've just recognized its existence. That's also another point that I want to return to. This is not something that I invented. It's just something I've synthesized from out of. It's the simplest thing in the world is spherical space. A linear 3D space is actually far more complicated. I mean, well, already you have 3 axes. Well, in spherical space, you only have 1. The universe, of course, only has 1 axis. It cannot possibly have 3. But mathematically, it does. Mathematically, there's a 3. And I'm coming to that. But you see, we have 2 systems that I'm going to just separate here. And on this side, we have lines. And this is the only, this side, this is, never mind. I thought it was dropping, oh God. All right, so this is spherical space, okay? This is all of space, and it's spherical, and it has 1 axis. But this is what science uses. This has never been used. To the best of my knowledge, I would pass a lie detector test on this, and believe me, I am very good at doing research, and I've been following this for quite a while. 2D, okay, right there, perfect. I just said it unconsciously, 2D. You see, this side, the spherical side, this is not a dimension. Only these line things, 1, 2, 3, and 4, and higher, only, Jesus, only these are dimensions. This, what is this? It's not a dimension, unless we're willing to split the definition of dimension into 2 definitions. We would have to have, if you were going to say it right, one of these, I'll just commit and then say, this, you see the screen reverses left and right, and I'm just like a monkey. And just, I can never get it straight, ever. I'm obviously, I don't know, I don't want to say retarded, that's a deprecated word. Some scientist to my left, oh, fuck. Well, that was my left, but you see, it looks like I'm pointing right on the screen, and it's just a feedback. Fucks, man. So obviously, my mind is not fully programmable, and this is a perfect example of that. I said 2D is just reflex. It's just like doing this. I'm trying to point over here, and I go, it's not a dimension unless you're willing to say that there are linear dimensions and spherical dimensions, which raises an interesting question. Is there only one spherical dimension? No, there's an invisible one too. Albert Einstein discovered the invisible sphere. It sounds like I'm making this up. And it sounds like this is the rowdiest, like, who is this guy? He just got off the carnival train and is now talking to the weeds out in the desert. So we have 4 linear dimensions that we've been able to deal with in science. There's 4 linear dimensions. But what I what I've offered to serve up to humanity for your dancing and dining pleasure, I guess, is spherical space. In other words, you just erase all the lines, you scratch, 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 and now there's nothing, and then you just make a sphere and you're done. You have all of space very conveniently tied up in a nifty little package. Just make a little knot, and oh, there you go. There's your universe. It's a sphere. Well, actually, that's true, and that is my discovery: is the universe actually is a sphere, except for Albert Einstein. God may God bless him to the eternities. Do we not love Albert? Oh man, but he left us with some real tough nuts to crack. Well, I mean, he certainly gave us enough. I mean, it's not like he was trying to hamstring us so we'd never make the finish line. No, he looked through the fog. It's like he saw that there's 4D. That had just been discovered was 4D geometry. And he went, well, all of you have to do is make fun of the axis time. How he did this, well, I told you, he used two tricks, but he still had to do it in his head. But the result was he found 4D space. That he did prove that. Just because he changed one of the axes to time. Now you might say, well, that's cheating. He made one of the spatial axes time, so that's not really 4D. That's imaginary 4D. Exactly. That is the amazing part. It is imaginary. It has to be because we cannot see it. We'll never see 4D. And I've simply explained it geometrically, Einstein's discovery, that we do see in 2D. But the universe has a reflection, and it actually is called that in geometry. It has a reflection sphere. But in physical space, the real universe, where if if the sphere fills space as I say it does, there's no room for another sphere. Well, there was no room for another linear axis either. Once you make the third line, you've made cubic space. If you add another orthogonal line, it's hypercubic. Well, he proved that exists. It's hypercubic space. But unfortunately, it's not straight lines. In other words, it's not hypercubic. It's hypercurved. And so it's hyperspherical. You could say that, but it's not spherical. It's hyperbolic. It's because when you have 4D space, which you cannot see, but it is known to exist, even in linear space. These are called polytopes, or polytopic space. It's higher dimensions of linear space above 3. We say that we see in 3D, but now you know that the right way to say that is that you see in spherical 2D, which you interpret as linear 3D. That's the right way to say that. This has been a fruitful expose so far, but I haven't yet talked about the replacement term that I propose, which I am certain is accurate, and it is my job to get this right. That's why I'm so concerned about this. This is on my desk. Nobody else can or will do this. Only I can, and only I could. And I will. I am. I feel very fortunate to have been chosen for this insight. This will change humanity. This will change science. This will change the future. Oh, much for the better. I don't see any weapons of mass destruction coming out of my discovery, but who's to say what the the analysts will figure out, oh, wow, that'll make a bomb or enable us to split genes so we can make dinosaurs and bring those lovely creatures back. So proportionality is the replacement term. You have dimensionality over here and then here, and these are the lines. Dimensionality refers only to linear space. That's the point. Linear space, and you could say the linear space system. In fact, that's correct. The linear space system includes 1D geometry, which is numbers, very simple. 2D linear geometry, which is Cartesian. And 3D, which fills space. You see, that's the magic number for linear space. And that's where it ends. There is no fourth linear dimension except in the imagination. It's not physical. It also isn't physical. It doesn't really emulate physical space. It just gives us a grid. That's all dimensionality is a grid. That's all it can do for us for space. That's why we have calculus. And in fact, that's why we have all the problems we have in mathematics. All of it comes from using the wrong number system, including division by zero and the incredible confusion caused by irrational numbers. All of that goes away. If you made a list of all the misery that exists in mathematics that literally make people hate it, who probably shouldn't, I don't think anybody should hate mathematics. But there are far, far too many people, a far higher percentage of humans are simply incapable of grasping mathematics for no other reason than that it's misused and it frightens them. It should frighten them. It should frighten all of us as we're going through school. It did frighten me. I have a very, very peculiar attitude and relationship toward and with numbers. I have a very interesting history with numbers. It's not all good, I guess you could say. It's like I'm crippled or hampered or I have dyslexia. I see numbers very well, but I don't use them very well. And so, that's just me, but I mean, I do have to take into account my own psychology. When you're on a discovery vector, you have to take account of your own bias. It's the biggest danger in a discovery sequence. If you think you're about to discover something, this is why discovery science is so exciting, because you can tell you're getting close to something. It's like solving a puzzle. It's like in forensics, getting to solve the case. You can feel it, but you don't have it yet. But you can sense that you're getting close. Well, that's when you can make some serious mistakes because you want to get the answer. And so you're too liable for compromise because of desire. I felt that. And so I need to be more precise in my terminology. That's what I'm doing now. So dimensionality only applies to linearity. It's a word that's specific to this side, the lines. 1D, 2D, 3D, and 4D. These are linear dimensions. When you start the other way with a sphere, you only have one axis, which is a great simplifier, but it's not linear space anymore. Everything is curved. There are no lines. In fact, that's the whole point of integrating to 2D space, is all your three lines are sucked into the algebra of the new geometry. You don't lose your linearity at all. It's there. But it's algebraicized in an object. This has already been done successfully to get rid of complex numbers, that tremendous curse, which the analysts think is God, the God of mathematics is complex numbers. I am not exaggerating. In fact, the fundamental theorem of algebra refers to complex numbers almost directly. And what a boner, what a tremendous error, what a mistake was complex numbers. No, it was an intermediary tool until we could. Science is progressive. And by God, I actually did it right that time. Maybe I am programmable and not retarded. Anyway, this is the direction I meant to go, although, whatever. Science is progressive, and we do make mistakes that we can see in retrospect because we fix it. But it worked for a while. I mean, it got us in the right direction. Complex numbers are, first of all, you will never get rid of them because they're an excellent analytical tool. But it's only for linear geometry. It's only for what is done really in industrial science, for making things on Earth. It's the earthly geometry. And that brings up another point. I mean, I've been harping and emphasizing on the fact that there's two surfaces for a human, the one that we're born on and the other one. That's called Earth and Heaven, in the direction that we see it from. In the Bible, it's heaven and earth because obviously that's the right heaven and earth. But from our perspective, it's earth and heaven. That's the order. We're not born in heaven, although we're born inside of heaven, pretty much at the center. From the human perspective, the center of the earth is the center of our universe. Oh, there's nothing superstitious about saying that. Oh, you're absolutely geometric. You have to say that if you're into geometry because it's true. We are standing on the center of the universe from that frame of reference. From the human frame of reference, we're standing on a sphere with all of our feet pointed at the center of the universe. It's only that one point that's the center of the earthly universe. It's kind of a variation of the many worlds theorem, and you may mistrust this, but it's one way of looking at things. It makes perfect geometric sense, so there's nothing wrong with saying that you're at the center of the universe. You are. Definitely at the center of the universe, as long as you read the footnote that it's only for you. The rest of the universe is not the center of the rest of the universe because your universe is centered on you. See, science is trying to get away from that. We don't want to have the center of the universe here because, of course, it's not. But where is it then? Where is the center of the universe? Well, I've taught you that. There is a center to the universe. It's not Earth, but Earth is part of it. The center of the universe is, in a sense, everywhere. But you can be much more specific and accurate than that. It's the center of the universe is in the protons, not in the electrons or the photons. It's in the protons. And then that's the bending of space. But there's another aspect to the bending of space, which is the biggest mind blower in the history of humanity in terms of our understanding of science. And that is the incommensurability in the fundamental binary split in reality. And this is a known thing, so I'm not just stringing funny words together. Electricity and magnetism, as you know, electricity and magnetism are the same thing. That was not known until James Clerk Maxwell proved it. It's one of the most fundamental insights ever achieved by the mind of man, that electricity and magnetism are the same thing. And there's a footnote, a big long one that goes on for many pages about what do you mean by the same thing. Because obviously they're not the same thing. That would be like saying that the proton and the electron are the same thing. Well, yeah, we're getting there. that doesn't make as much sense, but you see, this is called a duality. But duality has many definitions too, and we need to be specific. It's an existential duality. Two things that only exist together. Electricity never exists without magnetism. I think you know that. And vice versa. So that's an interesting relationship. That is the exact same relationship as exists geometrically between the curvature of space and the manifestation of time. They always occur together. You cannot have space without time. And you cannot have time without space. Those are worthwhile Gedanken. Everything at this level is extremely profound and worth at least a Gedanken experiment. You have to think to yourself, is space the same as time? And maybe you kind of get that. Well, they're the same, but you have to say why. This is 2D logic, by the way, where you have to say everything twice. That can get tricky. Our minds are not trained to think in two modes at the same time. We have to switch between the two. The universe doesn't switch between its perception of time and its perception of space. But we have no choice but to separate the two. They certainly feel different, but in a sense they're not different. Space and time are manifestations of the same thing that we call universal space. What I've been doing is trying to get the geometry of that relationship that Albert Einstein uncovered. The time and space themselves are perpendicular. They're orthogonal. That's one of the most amazing insights that's ever been achieved. I've tied this together with Max Planck's incredible breakthrough, which I've called the greatest discovery in the history of science, bar none, is the discovery of the quantum number. Those are perpendicular components to one number. So the geometry of orthogonality is built into 2D space. Do you understand the significance of what I just said? The utter profundity. And this comes to the main point that I wanted to talk about tonight. Now that I've dealt with proportionality, which applies to spherical space, and dimensionality, which applies to linear space, I now wish to talk about space, the final frontier. I'm on sabbatical from that lecture series, which is called Space, the Final Frontier. Well, space, when you encounter the final frontier of space, it depends, of course, on context. If you're in a spacecraft, I want to get back to the tours. I want to get back out into the universe with you so I can teach you the beautiful things that are out in the universe. But I have been detailed for this work. I did not ask for this. I did not expect to find a new geometry. It still sounds strange to me to say this, but it is a brand new geometry. Nobody's ever come up with this. And this is the right time for it because it just unlocks the floodgates. We have a lot of problems in physics, and we have a lot of problems in humanity, which in physics, they're not interested in understanding. What they're interested in is, it is understanding, but it's directed understanding in a direction different from that of humanity. They certainly work well together. We don't argue with technology. Technology is good, even though it makes, weapons. But it was meant to be good. So none of that is bad, but humanity has different goals of its own. Technology helps humanity, but it doesn't really change our original problems. We're trying to cope with reality, but the end result of that is not going to build a bigger machine. That's only for on Earth, which, as I've taught you, is kind of a trap. You'll end up trapped. When you go to heaven, you're free. So we're simply recognizing that we're dealing with stuff that's not for Earth. So it is a different system. Well, that's very important for this geometry, to understand the meaning of this geometry. It's not linear thinking. It's not going to result in what is practically dictated by linear thinking. Linear thinking is directed thinking. It comes to some, you almost are required to build something to justify linear thinking. But spherical thinking, you see, it embraces everything. So this is but this is pure geometry. It has nothing to do with philosophy or anything that I just said. It's to bracket this in the human equation. Is why this is so significant is not so much for industrial science, because this geometry, as far as I can tell, is not going to change the way things are done on Earth with linear numbers. I don't see how it could. It seems to be almost a brand new system that is simply not of Earth. It's not designed for use on Earth. And so the adage comes true. Not myself am so heavenly minded, I'm of no earthly good, but rather the geometry that we seek for wisdom, for the ultimate, for the real goal. See, that's what I'm doing. I'm trying to get the truth. In order to get the truth that helps myself and perhaps humanity, that's what science would do. We're telling everyone what the universe says to help us all. To help us. Do what? Very, very deep question. But this geometry completes your number of choices in how you can approach the universe. You're no longer constrained to the university slavery system of having to learn linear algebra. It's monstrous if you're leaving out the other geometry which gives you understanding. This geometry is the geometry of understanding. This is synthetic geometry. We no longer need that term, synthetic geometry. Spherical geometry, as you go to learn it, makes you what you want to be. To the degree that you engage spherical geometry, you will have your answers. They'll be right in front of you because you're looking at the geometry of understanding, the geometry of linear numbers, and dimensionality, all the way up to what Einstein used, is not for understanding in the human sense, which is why Einstein's field equation is at once the greatest single formula ever invented by the human mind, is Albert Einstein's field equation. It's just kind of coincidental that it's also the hardest equation ever formulated. It literally cannot be computed by a human, although there are a few that could do a typical field equation perhaps in a few months. But nobody can do one of those in a day. And it takes supercomputers to actually perform the mathematics. It's 4-tensor calculus. It is impossible for a human mind to actually do that calculus easily. It would take me forever, or centuries, or whatever. And so we need supercomputers to work out GPS coordinates. It cannot be done on paper because it's 4-tensor calculus in hyperbolic space. So the greatest equation, one of them, in a sense, in its class, it's the greatest equation. It's the hardest. It's the hardest to figure out, and it's the hardest to compute, and it's the hardest to see. And I've proved that it's wrong. It's absolutely wrong. It couldn't be more wrong in terms of understanding. It leads you directly away from understanding. I took it apart and showed you the springs and screws that make this fucker work. The Einstein field equation, you could either call it the greatest act of genius or the greatest act of folly. And either one is appropriate. But it's superpositional logic here, because the linear algebra system is only meant for Earth. And Albert Einstein used linear algebra to solve a problem for which linear algebra was not designed. I have the right approach to universal gravity. And it is right. It is superior. It's more original and it's better. It's better for humans. It's better for everybody. The only thing it's not better for is making a GPS system. Because Albert Einstein is the analytical solution that gives a computational result. My geometry is not going to give anybody any computational results. It's not for what you do down here on Earth. There is no, like down here we have division by zero, right, in linear algebra. Notorious problem is division by zero. Well, in human affairs, that division by zero, you might say that that's thermonuclear weaponry. That's the division by zero error as we use linear algebra. In spherical geometry, there is no such division by zero. You can't hurt yourself with this. Nobody's ever going to make a bullet with my geometry. The only thing this is good for is for transcending the human situation. It's so you'll understand the universe, so you'll be happier. It's not to make you money. If this makes you money, it's because I don't know how you can make money with this geometry. It's not for the slavery system. It's not for Earth. It's not for the world. It's not for the governments. It's not for your peers. It's not for the typical scientists. It's for wise men. It's for men who want to improve in the right way. Before the open face of heaven, fuck the humans, fuck the government, and fuck everybody else. When you go to get the truth, it's only going to be for you. You're going to have to betray. Jesus said this. You're going to have to love this more than your own family, more than your own parents, which it violates one of the commandments. No, it doesn't. Of course, there's something that transcends the respect you have for your parents. How about the respect you have for your Creator? 38 minutes. I'm on sabbatical, but I had to make these points clear, that the geometry that I have discovered is not for the common man. And if you're a common man, you're going to drop out. You're not going to make this. But I'll be talking about this for the rest of my life. And if I am given the go-ahead, I'll be talking about this forever. This is what I do now. But you need to know what you're in for if you stick with me. You're not going to make money. You're not going to please your superiors or get yourself ahead in any way here on Earth. This is to get you off the Earth. And if you go out there and don't come back, I'll be right behind you. But we're getting out of here using our rational intellects and staying moral. You have to stay moral. Try it here in the world. You can't stay moral with worldly thinking. You're going to have to get to heaven with your mind. It begins in the heart because love is the most powerful force in the universe. You have to love heaven first. You'd better, but you can't force someone to love. That's one of the most beautiful things I like. I'm going to say that again. You cannot coerce love. It either latches or it doesn't. It's certainly latched on me. wish to express that with every fiber of my being, but I cannot do so with religion due to the constraints placed on the intelligence level of my peers here on earth. They can't see that, they can't tell they can't tell their left hand from their right. But I pray that you can, or you'd at least like to. Well, that's called chirality. Stick with A&E. 40 minutes. We're on sabbatical, but obviously I can't stop. That's normal for a scientist on a discovery vector. We'll be back. Stay tuned.